Alrighty, so my research paper was on tissue culture and its economic and global impact that it's making on the world today. So tissue culture is when you want desired traits from a plant, and you take a piece of it, you take it off, and you put it in a petri dish, and then you pretty much just genetically cherry pick traits that you want, and then it becomes a plant, and you're able to grow it through mass propagation. So the reason why would they want to do that? You would ask, like, why take a piece of a plant and get these desired traits? So plants are like humans. We both produce through sexual reproduction. And so in a plant, when you sexually reproduce, it happens when the egg and the cell flower fertilizes through pollen from the stamen of the plates. From the plants. The stem of the plant is home to the cells that contain DNA. During sexual reproduction, DNA from both parents is combined in new and unpredictable ways, creating these unique plants and their characteristics, say their pest resistance, their size, color, just like humans. However, this is where researchers have developed a method of growing exact copies without seeds or sexual reproduction, and that's when you cut it off, you put it in a petri dish, and you grow it. So this is actually called micropropagation. It's kind of in the family of cloning. Micropropagation is when you take the chromosome from the shoot and you store it in a petri dish. Micropropagation, once again, allows you to take the desired traits from the plant and explants and sterilize them, and this is where they grow and you get the genetic modified plant you want. So here's a real life impact that it's taking on. Western Asia and Africa, they are struggling the most with poverty on the world. So they have two rice species that they want to combine because they have specific traits that they think would be perfect to create the perfect rice species that could fight off pesticides, poor farming conditions, and the weather. So there was the rice trait of Orzara glabrea, which is the Asian rice, and then the African rice was Oryza sativa, and they couldn't ever combine them because the problem is the two species were so very different at the time. So for years they kept on trying to produce them or to cross-produce them, and the rice failed. After cross-fertilization through removing the embryo, called the process of embryo rescue, which is a form of micropropagation, they were able to create this genetically modified rice that could withstand any of the conditions and grow in the Sahara Desert and fight off droughts and stuff like that, which is going to completely fight off world hunger, which is just why it shows the potential of tissue culture. And you're thinking, well, why aren't we doing tissue culture everywhere? Why is this not a more common thing? The problem is it's a very slow, hard, and long process. It's extremely expensive to do it because it takes forever to grow. You have to put in a petri dish where you manually grow it, and there's a lot of other variables. So it's not completely there yet for great commercial use. It does have a promising future, and hopefully we can continue to use it in other poverty-stricken countries, or even in the United States, God forbid something were to happen, where there's a something happens with a disease, we're able to fight off a famine because we can use it through tissue culture to find specific traits that we want to fight off certain things.